Hey guys, here are the answers to homework number 4 from section 6.4. The first thing I'm going to do is I'm going to just scroll through the answers real quick. You can pause the recording and check your answers, and then I will go through and I will explain how to do each problem, and you can just scroll through the video and only listen to the answers or the explanations of the problems that you need help with. So here we go. Let's give you the answers first. Here's the answer to 1A and 1B. Here is the answer to number 2. And here are the answers to number 3. Here is the answer to number 4. Here's the answer to number 5 and number 6, A and B. And here is the answers to number 7. And I think that's it. All right. Let me go ahead and explain how to do each problem. So number 1 is asking you to write let statements. It says on Friday, 150 people went to see this performance in the school auditorium. Children and adults attended. So I think we can assume that all the children, all the adults made 150 people. So I think my equation would be the number of adults plus the number of children adds up to 150. So I'm going to need my let statements to be the number of adults and the number of children, I think. And I might let A equal the number of adults and C equal the number of children. And since 150 people went, I think I can assume that the number of adults plus the number of children adds up to 150. As far as part B goes, I have the cost of a new CD is $14.95 and the cost of a video game is $39.99. And Wade spent $84.84. Okay. So I think you would calculate the cost by multiplying the number of CDs you bought times $14.95 and the number of video games you bought times $39.99. And if you added those two amounts together, I think they would equal $84.84. So I think the two things that I do not know is how many of each thing did I buy? And that is what my let statements will be. I will let C equal the number of CDs bought. And I will let V equal the number of video games bought. And then my equation would be the cost of all the CDs, right? So the cost of all the CDs would be $14.95 times C, which is how many I bought. And the cost of all the video games would be $39.99 times V, which is the number of video games I bought. So if this is the cost of all the CDs and this is the cost of all the video games, and I know that those costs all add up to $84.84, that gives me a valid equation. We're on to number 2. All right, number 2 is a really interesting problem, I think. I'm really curious how many people got this correct. I have these two people that are 3 miles apart. All right, so you got Jonathan here, and you got Laura here, and they are 3 miles apart. And they start traveling toward each other. And so here's the thing. These two distances, their two distances have to add up to 3 miles. I don't know what either of them are, but I do know they add up to 3 miles. So it says in the problem that right here, I guess, that Jonathan traveled m miles. So if Jonathan traveled m miles, the question is, m plus what gives you 3? Or how many is left over for Laura to travel? Well, she had to travel the rest of the 3 miles, whatever's left over that Jonathan did not travel. And the amount left over would be the total minus what he already used up. So it'd be the total 3 miles minus the amount of miles that he traveled would be what's left for her to travel. 3 minus m. We go on to number 3. All right, so in number 3, if I want to solve this for x, first I need to get rid of the 5 by adding 5 to both sides. And over here I would have y plus 5, and over here I would have 2x. And then to get the x by itself, I would divide both sides by 2. And there's my answer really right there. X is equal to y plus 5 over 2. In letter B, to get the w by itself, first I'm going to get rid of this term that does not have a w in it by subtracting it. I'm going to subtract 9 from both sides. And that gives me p minus 9 equals negative aw. And then I'm going to get rid of the negative, I'm going to get rid of the negative a. Since it's multiplied by the w, I'm going to divide by it. And frankly, this is a pretty good answer. However, I did not put that as the final answer because it's kind of not common to have a negative number in the denominator. So what I did is I multiplied the denominator and the numerator by negative 1, which gave me a positive a down here. And in the numerator, it made the 9 positive and the p negative, which is the answer I told you when I went through the answers. But either one of them, frankly, is a correct answer. In letter C, I want to get the m by itself. So first I need to get rid of the 6 by adding 6 to both sides. Now the 2m is by itself. And then I would divide everything by 2. And I would get m equals 4 divided by 2 is 2, and 10 divided by 2 is 5. And finally, in letter D, I want to get the y by itself. But you know there's a y on both sides of the problem. So if I want to solve this thing for y, I need to get the y's on the same side, or I need to eliminate one of them. So I would probably eliminate the minus y by adding y to both sides. That gives me bx equals negative 1y. And then I would divide by negative 1 to get rid of the negative 1. And this would be negative bx when you divide it by negative 1. All right. We move on to number 4. I think number 4 is actually the dumbest question I've ever seen in this book. So I have these 5 basketball players, and what they want me to do is they want me to work on the substitution method here. So I am substituting Barbara for Allison. So goodbye, Allison. Hello, Barbara. Barbara. And Lakeisha for Melinda. So goodbye, Melinda. Hello, Lakeisha. And so my starting lineup will be Lakeisha, Samantha, Carly, Barbara, and Kendra, which is what I gave you when we did the answer key. Number 5. All right, the big thing in number 5 is they want me to convert 260 weeks into years. And so to do a conversion, I start with the original unit, which is 260 weeks. And I made a fraction out of it and just put it over 1 so it'd be a fraction. And to convert that into years, I need to set up a conversion fraction that uses weeks and years. And my conversion fraction would be this fact right here, that there are 52 weeks in 1 year. So that is really just a giant 1, because 1 year and 52 weeks is the same. But what happens now is, since it's a conversion fraction, the weeks cancel out, and when I multiply this, my answer will be in years. So I go ahead and I multiply the tops, and I multiply the bottoms, and I divide my result, and I get 5 years. Number 6. Number 6, they want me to write the first 5 terms. Okay, well, here's what I know. Man, I hope I gave you the right answer for this. I'm not sure I did. The first 5 terms, let's see, I know that this is the 0 term. And I know this is how much it's the common difference, right? It's how much it goes up every time. So the 0 term is -5. That means the first term would be -5 plus 2, which is -3. And I would just keep going up 2 every time. So -1, 1, 3, and 5. And as I was thinking about this, I guess probably the way you would rather me do it is you'd rather me take 1 and put it in for n, and that would calculate the first term. You could have done it that way, I guess, and not had to realize that this is the 0 term. So maybe we'll do that over here. Or maybe not. They told me the first term. The first term is 3. And down here, this is telling me how to calculate the next term. It's saying any term is equal to the previous term times -2. So I need to take the previous term, multiply it by -2, multiply it by -2, multiply it by -2, and multiply it by -2, and I get my 5 terms, right? And this takes me to the last question where I had to solve by the equal values method. So the equal values method says that if this is equal to y and this is equal to y, then they must be equal to each other. So I set them equal to each other. And if I were solving this, certainly without a calculator, the first thing I would do is clear the fractions by multiplying everything by 3, right? This is the fraction busters. 3 times 2/3 is 2. 3 times 9 is 27. 3 times 5 is 15. 3 times 4 is 12. Then I would subtract 2x from both sides. And maybe at the same time, I would add 12 to both sides. And I would get, let's see, let me go back to green. I would get 39 equals 13x. And then all I have to do, of course, is divide by 13, and I get x equals 3. But I'm not done. Once I have x equals 3, to get the rest of my solution, right, to get the y value, I need to take the 3 and put it back in up here for x. So y would equal 5 times 3 minus 4 when I do that. That'd be 15 minus 4, which is 11. So I get x equals 3, y equals 11, which would look like that, I suppose. In the part B of this problem, again, I'm going to set 3x plus 25 equal to, well, I can't do that yet because this one does not have the y by itself. I guess first I got to get the y by itself. That's a little bit sad. So here I might subtract 4x from both sides. Then divide everything by 2. And I get y equals negative 5 minus 2x. And now I can use the equal values method. Both of those things are equal to y. So I can say that 3x plus 25 equals negative 5 minus 2x. And to solve this, I'm going to add 2x to both sides, so the x's are on the same side of the problem. And at the same time, I'm going to subtract 25 from both sides so that the numbers are on the right. And I get 5x equals negative 30. And I would divide that by 5 and get x equals negative 6. So that's half of my answer, right? And I need to take that and put it back in up here for x to get the other half. So y would equal 3 times negative 6 plus 25. That'd be negative 18 plus 25. That would be 7. Y equals 7. So my ordered pair is negative 6, 7. All right, hope that helps. Good luck with the notes.